My name is Leo and my register number is URK24CO 2005. This is Data Structures and Algorithms Laboratory first experiment, which is implementation of stack using data structures. So stack is a linear data structure which uses last in first out principle. So what is last in first out principle is like the input which is given in the last will be taken out as the first output. So if I give three values 10, 20, 30, the 30 is I'm giving the 30 as the last input. So when I want to take some output from the stack, only the from the last element I'll be removing. So if I insert 10, 20, 30, I can only be able to take elements like 30, 20, 10. So that's the last in first out principle and stack uses it. So over here, I have six functions in the stack: push, pop, peek, display, check if full or check if empty, and the seventh one is exit. So the push or pop is used to insert and delete elements in the stack. So push is used to insert the elements, and pop is used to delete the elements. So as I told, the pop function works basically on it deletes only from the from the top of the stack. So as I okay, I'll run the code and so over here I have the six functions. So at first the stack is empty since I didn't insert any elements. So I'm inserting three elements. So I have here 10 and 20 and 30. So over here I have pushed three elements and here I have mentioned that stack size is 3. So now I have, since if I give display, as you can see, the stack elements has 10, 20 and 30. So which means the stack is full. So if I check that whether the stack is full or not, it will show as true because the stack is full. So, and if I want to pop some elements, as I told you, it will only pop elements from the top of the list. So if I give pop right now, it will pop the topmost element, which is 30. So as you can see, when I give 2, the topmost element, which was 30, was popped. So now if I give display, only two elements will be present, 20 and 10. So that's the function of push and pop. So the peek function is it will print the topmost element in the stack. So as you can see, there are two elements on the stack and the topmost element is 20. So what the peek function will do is it will show the topmost element which is 20 on the stack. So if I give 3 over here, as you can see, the top element is 20. So that's so the fourth one is uh, display all elements in the stack. So as you can see, the position of the stack is declared by a variable called top. So initially the top will be having a -1 value. So if the top value is -1, which means the stack is empty. So if the top value is equal to size -1 because the index value starts from 0. So if the top value equals to the size -1, that which means the stack is full. So over here, in all the functions, will be using the function is empty or is full because if I want to pop elements, like if I give pop elements, first it checks whether the stack is empty or not. So if it is empty, we can't pop any value, right? So yeah. So over here, push function also. If the stack is full, we can't insert any more values. So first it checks whether the stack is full or not. If else, if it's not full, it will be inserting the values. As you can see, well, display in the display function, we are using a for loop with iteration value of top, and we are displaying the value. And yeah, this is the switch case which we have used over here. So this is the first experiment which got, and as you can see, well, 7 is exit. So the real-time application of stack is will be using the in browser in Firefox or Chrome, if you move from one page to another page, if you want to go to the previous page, we'll be clicking on the undo icon, right? So that undo icon is working on this stack architecture. It works with the stack flow. So this is the first experiment.